Perfect. So it looks like we have most of our participants. So hello and welcome everyone. I'm Carolyn Mooney, the CEO and co-founder here at NextMove. And thank you all for joining. Ryan and I are here to chat today with Karla Hoffman. Ryan is my co-founder here at NextMove and also a former PhD student of Karla's. So we are super excited to have her here today to talk to us about optimization and operations research. She is a professor emeritus at George Mason University, where she was part of the Systems Engineering and Operations Research Department of the School of Information Technology and Engineering. She has an amazing background in all things optimization and has had an amazing career and been recognized at various organizations, including NIST, and also as a former president of Informs, one of the largest optimization communities in the country. And so I know we'll hear a lot more about her experience today. So welcome, Karla. And for all the attendees that are with us today, we'll look to answer kind of any questions you have in the chat or in the QA boxes. So with that, we are going to dive in. So today, we'll talk about optimization as a discipline. We'll also talk about optimization in practice and in industry and how optimization is changing and what the landscape looks like going forward. So I'll stop sharing so we can see everyone's lovely faces and we'll get going. So maybe the first question I have is for Karla. So how did you get your start in operations research? And how do you describe what it is to the everyday person? We get this question all the time in our work here at NextMove.
So first of all, thank you. I'm looking forward to this conversation. I started probably the way a number of people start, which is that I loved math. So I was a math major without any idea what I would do as a career. And when I finished my bachelor's degree, I still didn't know what I was going to do. I had an economics minor, so I decided let's get an MBA and see what the world of business looks like. And I really was very lucky to have my first professional mentor, who was Jerome Bracken, who normally taught at Yale, but as it happened, this semester was teaching at George Washington University, which is where I was getting my MBA. And he just introduced optimization to me. And I said, I love this. I'm the kind of person who walks into a store and says, really? Couldn't you organize this better? Why do I have to go from this aisle to some other aisle, halfway across the store just to get the two items that I need that are related to each other? So, and I tell my students that if you like math and you like solving puzzles and just thinking the world could do things better, then you belong in this field. And so your question, what is OR? I take a very broad definition of OR. It's using modeling to determine decision alternatives and then choosing among those alternatives to find the best. So it's really just using math and science to improve decision-making.
That's awesome. I know oftentimes we hear kind of AI and ML in the same kind of realm as OR. Like, how do you view the kind of the interplay between these different, like optimization and decision making techniques, and what's available kind of in the broader AI and ML spaces? Like, I think we get a lot of confusion there between optimization and ML.
Well, since my definition of OR is very broad, I could argue that it includes data analysis, statistics, machine learning. Yep. But I think what makes optimization somewhat unique among these is that mostly statistics and machine learning use data from what has happened. And optimization actually considers what are the constraints on this problem, what are your objectives, and then tries to choose among the alternatives. And so it may come up with alternatives that nobody has ever considered because they're sort of out of the norm box. And I think that's what's really important, because humans have lots of biases that we don't acknowledge. We want to confirm what we already know. We want to consider only among a very small number of alternatives. And we all know about correlation bias. So I think we need decision support tools that help humans think more broadly.
Gotcha. No, that makes a lot of sense. I know, the field of operations research has probably changed a lot over the last, 10 or 20 years. Maybe both of you could give some perspective on that, what you've seen kind of in the field and how it's growing and changing.
Well, I guess, no, you can start.
I was going to say that I think some of the interesting pieces there from my perspective really are that operations research and optimization seem to be going sort of down a similar path to what statistical inference did 10, 15 years ago with data science, where you really saw it start to get integrated into technology stacks and become like a production software systems in a way that it wasn't before. I remember when I first started studying the field, it was very much geared toward a human operator in the loop decisions, and decision support meant providing some sort of modeling capabilities to a person who would then execute on those things rather than like a software microservice that would be making automated decisions.
Yeah, I would agree with that. I think that we started with large corporations using mainframes to help in very, very expensive decisions. And they were always in the planning stages. And now the world has changed. We're used to everybody is used to decision support systems that tell them how to get from A to B, that you can have voice assistants who give you answers to any questions you might think of. You have a lot of things that make day-to-day decisions have really changed. And I think the world is more comfortable with decision support systems that are, in a certain sense, automatic. You can override them, but there's a certain amount of automation to them that didn't exist before.
Yeah, it seems like there's a lot of expectation too from consumers, right? And I think, that's driven a lot of use of optimization in the commercial space, right? Like, consumers are expecting there to be, for decisions from businesses to change, right, as new information arrives. So I think, airlines, right, they have weather impacts, right? They're, consumers expect those schedules to change and modify from there. I think we've heard a few times that optimization is a solved problem. So it sounds like it's had a lot of growth over the last 10, 20 years. Like, do you think that's true, or why do you think that perception exists?
Well, I think our algorithms are continuously changing. Part of the reason for the change is we're seeing new problems. As we are capable of solving problems that were never solved before, people look to us and tell us about problems that they've been worrying about for years, but just assumed they were unsolvable. And now we have a lot of hybrid algorithms. That is, that we can use the cloud and a variety of the algorithms that we learned and put them together to be able to solve what once was considered unsolved problems. And I think that's an interesting thing, is as we get more successful, we get to hear new problems. And new problems require new algorithms and new ways of thinking about something we never thought about.
Yeah, I think one thing we've seen a lot, especially with some of our customers, is a lot of side constraints that aren't necessarily studied as much, right, in academic work. Like when you start to have these real world problems, you have interesting constraints pop up, for labor law reasons, or just the way that the business does their work, right? So I think there is a lot to be said for the problem is growing and changing. Do you feel like there's more awareness though of optimization and OR as a discipline now than there was before, or like how have you seen that like change?
Oh, I think the corporate world, the gig economy are desperate to get the best solution they possibly can. They understand the world is changing. They know that they have to get decisions in what I would almost call zero time.
Yep.
And yet these, as you indicate, these solutions have to be usable. They can't forget about the real world and all of the rules that have been put into place over years within these businesses, if these
Yeah.
businesses were over years. But I think that one of the ways in which optimization is learning that is by using humans as well to challenge the algorithms. And every time that algorithm doesn't work, you learn a little bit more about the problem.
Yeah, definitely. Well, and I think especially right now, in like the macroeconomic environment, right, optimization is crucial, right? As everyone's trying to do more with less resources, right, and still be able to deliver great experiences, right, for their end consumers, whether they be businesses or individuals like ourselves.
Yeah,
Um,
and I think we're moving into areas we never considered, like
yeah,
medical diagnosis and treatment, routing communications that include satellites and fiber
yep,
and wireless, things that occurred because of the COVID pandemic. I
yeah,
mean, we just have a lot of new, exciting problems.
Yeah,
yeah. And through,
oh,
oh,
sorry.
sorry, again.
I was going to say it's interesting with some of the applications that have been developed recently because when you look at how optimization tends to be covered in journalism and reporting, oftentimes they talk about how the traveling salesman problem is this big unsolved problem, right? And if only we had this magical quantum computer that could solve it for us. But from an optimization perspective, we usually think of it as more or less solved. Like we can solve very large TSPs very quickly, and it's when they get realistic constraints or aspects to them that they become difficult. And now we see like routing problems where there are drones involved and one vehicle can contain another, or there's synchronization between multiple different types of vehicles, like different kinds of food trucks and replenishment vehicles. And so we can
Or
see
three
these
different
kinds
pickup
of yeah,
spots.
right. You can take a break in one of 5 different locations, and it's kind of up to the driver where. And so as these smaller decisions become incorporated into these problems, they become harder and harder.
Yeah,
Definitely.
I do think the problems and everybody seems to concentrate on the traveling salesman problem from a journalistic perspective, rather than the true problems, which are vehicle routing with all of its side constraints and all of its issues associated with who is doing what when. They
Yeah.
become much more scheduling problems.
Yeah. Yep. And task assignment for sure. Um, so actually with that, I would love to hear from you, Karla, on maybe an interesting optimization problem that you helped solve, and how you went about that process, with that company. Like, how did they know they needed optimization to solve the problem, and how did you step them from kind of like where they were to fully optimized space?
So I'm going to talk about my first real-time experience, which was with a concrete company in Northern Virginia. And you asked how it came to me, and it came to me because an MBA consultant at the company noticed these long lines at the plant where the trucks get the concrete to move it to the customer. And he had heard of queuing theory and said, oh, this is a queuing problem. There are lines that are too long. And so he talked to Donald Gross, who is a professor in our department and at the time. And Don looked at the problem and said, well, what you need is more servers. but this is a plant that has a footprint that they couldn't expand. So they couldn't create more bays for trucks to get concrete. He said, the only thing you're going to have to do is move some of these vehicles to a different plant. And what was really going on is the plants were built decades earlier, where most of the construction was in DC or east of DC, and now most of the construction was west of DC. So it was very difficult to figure out what trucks should be assigned to what plant. And basically the idea was we would have, instead of specific customers being assigned to a specific plant, the trucks would go to a plant, get the concrete, deliver the concrete, possibly go to another plant, get it for either the same customer or a different customer, and circulate throughout the area. And that's when I learned that it wasn't as easy a problem as it didn't even sound easy at the time, but we didn't realize just how important weather was going to be. Routing in terms of an area whose traffic is terrible regularly. Customers.
I drove through DC the other day. I can definitely attest to that.
And the problem with concrete is that, let's say it would take 6 trucks to create this structure or basement for a major building. You can't stop it in the middle, because if you stop it, you start all over again. So that was problem number 1, is you had to have this sequence of trucks arriving when they need to arrive. And then you have the fact that the industry is remarkably optimistic about whether or not they'll be ready to pour concrete when it's specified. And then you have the hot issue, which is if concrete stays on a truck for longer than 2 hours in hot weather, then you might have to remove the concrete using a jackhammer or truly explosives. I met the dynamite man because he was the person who could get concrete out of trucks. So it was a very complicated problem. It was great fun, and it was great because the CEO of that company wanted the industry to change as opposed to keep the technology secret so that they would have an advantage over their competitors.
Gotcha. And so, like, with systems like that, do you think there is kind of what are the kind of key factors that allow them to take advantage of optimization? I mean, I think something that we've been seeing a lot of is, there's just so much more data available almost at every company to leverage in optimization models. And I think one of the things that I remember from my time at Lockheed, where we were running on, our own private server stacks, like that's just not a thing anymore, right? Like you have access to cloud computing. Are those the main factors, or are there others, or how do people kind of set themselves up to leverage optimization?
Well, one of the things that I applaud NextMove for is thinking about how to keep this system running when the managers change, when the data changes. So yes, there's far more data. So that issue is almost the reverse of the issue, say 20 years ago, where you had to have a data collection effort. Now you just have to figure out what's going on, when it changes and how it changes, but you also want to keep the data and the modeling in a language that a manager understands as opposed to an optimizer understands. And and you shouldn't force every single person to remodel a vehicle routing problem when virtually every industry has vehicle routing problems. So there should be mechanisms in place to say, these are the characteristics of my vehicle routing problem. And they may be different, and they may have to add some side constraints, but the overall process is
similar.
better understood. Yeah. And I think Ryan can probably talk to this better than I can.
I think that the data collection part is very interesting. It wasn't very long ago that every value that you fed into a solver was sort of precious, right? Like you had to sort of hand massage that or research it to come up with, oh, now I have the value 3. Okay. And now it's like everybody has a phone, which is constantly sending their location data, right? And, you have this sort of clickstream data of people going through your website and stuff like that. And it's much more of an extraction problem. And how can I figure out what is the belief state of a system to give to a solver now, as opposed to how can I actually even accomplish or construct a belief state?
Yeah. I think this is actually a really good transition to both of your work, right, in decision diagram optimization. And I wanted to get, a little perspective on, how do you think about that? What is the difference between, decision diagram optimization and more classic optimization techniques? And, how do you think it changes the way people are modeling optimization problems?
Well, I think there are two things. First of all, decision diagrams, like constraint programming, really treats the logic constraints very differently. And this is a really important consideration, which is that you shouldn't have to work. And I used to teach. Ryan can probably remember the pain of the session where all I'm doing is providing tricks to get the optimization to understand the logic of something really simple, like an either or constraint or a precedence constraint or a variety of things. And now there's really a much more natural computer science way of thinking about that component of the problem. But the other thing is we really stress optimal solutions. And I thought I would have said this earlier, but there are two issues in that. One is, if it's going to take an hour to prove optimality and you need a solution in 2 minutes or less, stop worrying as much about optimality and start worrying about getting the real problem solved as well as you can in the time. And also worry about, in the planning stage of configuring your business to be able to handle these problems, that the solution that you get in planning is not fragile. What you really want is the flexibility of how you've organized your system to be able to handle the anomalies. We know something is going to go wrong every single day. We might not know where, we might not know when, we might not even know how, but we really need flexibility. Whether it's airline scheduling, which I've worked on in the past, or it was the concrete company, or it is vehicle routing and scheduling, things happen. And we need a system that's capable of handling that.
Yeah, I think that's something we talked a lot about at Grubhub, actually, was like, we didn't care so much about getting to like mathematically optimal. We really cared about getting to a good solution very quickly. Especially in the real-time space, because you needed to have a plan that was operational. You couldn't just say, well, I don't know, after your solve time. So I think that is a huge thing. And, in talking with operators, I think they're okay with that, not mathematically optimal, as long as, because oftentimes those solutions seem to also be on, like you're saying, like on a razor's edge, like they're dependent on everything going exactly to plan. So I think that makes a ton of sense. I guess I know we're coming up on time here. So, maybe my last question is, what are the biggest opportunities you see in operations research today? And what can we do better, like as practitioners of OR, as this space kind of grows and develops?
Yeah, well, I guess if you think about just how things have changed, Supply chain optimization was not something that the public would have used 3 or 4 years ago. Suddenly, supply chain is a term that the public knows. I think there are lots of things. Similarly, people didn't think about using mathematics or think it was possible to use mathematics to create new vaccines, to handle diseases. I mean, the world is really changing very, very quickly. And whether people know it or not, there's a lot of optimization that's built into all of this. And so I think it's a very exciting time. I think we learned certain things. If I use supply chain, we had the wrong objective functions. We didn't worry about resiliency. We didn't worry about what would happen. I mean, if it's true that the cheapest supplier is one supplier, it's probably not a good idea to get all of your supplies from that.
All your eggs in one basket, right? There's phrases for that.
Can't blame optimization for that, except for the modeling perspective that said we had the wrong constraints and objective function.
Yeah.
Right. I did what you told me.
Yeah,
exactly. But we should be using optimization to think, just think more broadly about the alternatives, think more broadly about your goals.
That makes a ton of sense. All right. Well, Karla, it has been awesome chatting with you today. We really appreciate you spending the time with us. And I just wanted to give a brief sign off for everybody that has joined us today. So if you are thinking about optimization, you're looking at it, feel free to check us out at nextmv.io. That's nextmv.io for Next Move. And sign up for our tech talks that are coming up. We got some interesting ones that are getting a bit more in the actual tactics of building and operating these models, both deploying them into production and also a deeper dive into, we only touched on it briefly, but decision diagrams and optimization, where Karla and Ryan have spent a ton of time. So thanks everyone for joining, and Karla, hopefully we have you back soon and we can chat more about these topics. I know we could spend way more time talking through various optimization problems with you. So appreciate your time.
Well, thank you.
Thank you, Karla.
It's been really fun.